Welcome to another episode of Power On, the Rheinhausen podcast. My name is Schaider, and today's topic is about digitalization in the energy sector, especially on power transformers. Our today's guest is Tobias Gruber. Hello, Tobias.
Hello, Christian.
Great to have you here.
Yes, thank you for having me.
Tobias, how long are you involved in the digitalization topic?
I started my career with Rheinhausen more than 10 years ago, and since then, actually, I'm working in that field. So I started for the voltage regulators, so regulating power transformers, and then more and more also dealt with topics around the communication of power transformers, but also getting values from the power transformers, analyzing the values, analyzing the data, and making recommendations. So it's been quite challenging and quite interesting last couple of years.
10 years is also a very long time. Can you shortly explain the difference between monitoring and digitalization?
Yes, it's actually a very good question, because typically also when we talk to power utilities, we see that there is a misunderstanding about what digitalization really is. So first of all, I would define it as the whole package, so to say. So getting a physical value of a power transformer, transferring it via communication, analyzing it, and having recommendations available. So the whole package, and also using the information maybe to regulate something. So you could also use automation or automation as a word there to describe the whole package. And then monitoring is only a subset of it. So monitoring is only to have online values available about the health status of the power transformer. But if you talk about the whole picture, about digitalization, again, it's to capture the data, it's to interpret the data, but also it's to use the data for regulation, for control of the cooling, for example, and also then having communication to other systems, to other transformers for paralleling, for example, but also to superordinate levels in order to maintain fleets, in order also to control the whole network.
All right. Where do you see the digitalization topic, especially on power transformers, compared to today's status and maybe 10, 15 years ago?
It's been a very interesting job that I had the last 10, 11 years, as a lot was transforming, not just in the energy sector, but in the whole automation sector everywhere in the world. And also we are still in a constant change, and everyone can see the changes on a yearly basis, basically. So the first step is, in the past, we as MR, for example, we had for every single function, we had a separate device. For example, I was talking about voltage regulators. There was a separate device for voltage regulation only. It could only do voltage regulation. And then there was another device monitoring basic values on load tap changes. This was another device. Then there were other suppliers that had a device for bushing monitoring, another supplier having a device for DGA monitoring. So many suppliers, many single devices, all had different technologies, all had different protocols. It was basically a mess. So if you wanted to automate or digitalize a transformer 10 years ago, you had to deal with a lot of challenges. So first of all, the challenges because you had to talk to so many suppliers, but also then the electronics back then. So especially in the automotive sector, but also in the industry sector, the electronic part has been greatly improved. So we have now electronics that we can use that is very capable, that is very robust, that you can rely on. Whereas in the past, maybe not so much. Maybe especially then on transformers, you didn't have the electronics which was capable of maintaining for many years. Now we have electronics that is. So this is the second big thing that changed over the last 10 years. And then also the last one being, you can see it basically everywhere, using the machine learning techniques or algorithms in order to analyze data. So in the past, you only had an idea about the physical model of a transformer. And everything you then did with the transformer was based on the knowledge on the physical knowledge that you had on this transformer. But now you also have a lot of new algorithms, machine learning algorithms. You have the calculation power to use those in order to have maybe even greater information. You have better information also. You have even earlier possibility to detect errors. And so these are the three big trends where you could see tremendous changes.
So artificial intelligence, collecting the data in one, that we're not talking just about monitoring. So we're collecting everything and going really the direction into digitalization. This was another one. And proven technology, to exactly summarize it. Where do you see the trend going in especially digitalization on power transformers, the next 2 to 3 years?
We can now see, for example, in the past, there were asset managers who tried these technologies already 10 years back. And they faced problems with the suppliers not being available for them, with the devices they failed, and also with the data they provided, as they provided a lot of data, but not really information really about the asset in terms of a recommendation or something. What we see, first of all, technologically, is that the devices are now capable not only provide the data itself they're capturing, but also having a recommendation, but not just saying, okay, I reached a temperature level or this gas exceeded a limit value or something, but for having probabilities about failures on the transformer. For example, you probably have a partial discharge in your winding. There was a partial breakdown in your bushing, for example, or your cooling system is inefficient. Maybe a fan is blocked or something. So these are really sophisticated and usable information that you can now use and utilize also within the asset management process. So this is step one. But in order to utilize it, the next 2 or 3 years, we can already see this now, is that now is the time the technology is ready to invest into that technology. And we see everywhere in the world, utilities are investing into that technology. So the first, or the 2-3 years that you said, is first of all having those devices available on transformers in order to capture the data, in order to be able to do risk-based fleet assessment online. This is really something where we can see this is what power utilities do right now in the asset management. But also when we talk about digitalization, it's more than just monitoring. We had this earlier on. And so also in the regulation field, you can see there is a lot of renewable energies. There's a lot of electrical vehicles getting connected to grids. You have a lot of volatile power flows in the grid. And so grids are operated differently. So you maybe also then need different algorithms to regulate power transformers. Maybe it's not sufficient to have a basic algorithm, but to have a little more sophisticated algorithm. Also considering the thermal capacity of the transformer, maybe temporarily overloading the transformer, many possibilities.
I spoke also to Wilfried Breuer, our managing director, about volatile networks. There is also a podcast available, and with Franco Pizzuto, our business developer for the VPD, the smaller step changer we have for the distribution transformers. So especially the EV topic, volatile networks, this is a very huge topic as well. So if you should be interested in, reach or look also into one of our other episodes. There's for sure interesting content for you as well. And Tobias, where do you see some challenges for the energy sector or for the asset owners when we talk about digitalization of power transformers?
First of all, I mean, we see now that it's really an urge for them to invest in that technologies, because we see knowledge drain. We see the very trained and experts retire.
The war for talents, we often hear
Exactly.
that term.
Yeah. Also the boomer generation, they retire. We don't have enough people coming after them. We don't have the capacity in the utilities anymore. And this will be even a greater problem in 2 or 3 years. So we have to invest in those technologies. So this is given. The first big challenge would be to familiarize with those systems. It's not been part of most of the asset management processes. So they first of all need to see what those devices are capable of, test them, and then also trust them and integrate them into their processes. This will be a very big step. And also one thing is to consider, how do you want to manage your fleet? So if you can't do it time-based anymore, especially not just with the existing fleet, but the fleet has to maybe increase by... There are utilities I talk to that want to increase their capacity by 100% in the next 10 years. I don't know how possible this is, but it's their target. So if you want to double your fleet with the existing people that you have, or even a decreased people,
you need a solution for that.
You need a solution for it, and you need to deal with it, and also therefore need a whole system that you work with in order to know when to go to which transformer and what to do on this. So you don't have a margin there where you can allow yourself having the same concepts that you had in the past to have it also in the future. So there has to be a shift. And this shift is a big challenge for everyone involved, for sure.
But budget-wise, we have then a challenge to get familiar with the different systems which are available. If I understand it correctly, it's then not just about the sensor, or so it's influencing the entire asset management strategy.
Yeah, for sure. I mean, if you think about a fleet now, of course, you don't have only new transformers. You maybe even have transformers that are 50 years old or maybe even older, and they still need to be in the grid. I mean, you've seen so many transformers. How many are older than 50 years?
It depends in which market you are looking now. But when you look, for example, in Germany, we have a lot of older transformers. Maybe they saw less stress, so they are for sure good to go. As you said, you have most of the time a mixed fleet. New transformer, mid-age, old, shortly before retirement.
I mean, the first step is to always have a knowledge about the transformers in terms of the health condition of them, to rank them in a fleet assessment, and then to see which measures to take where digitalization will play a role on, and getting a prioritization, basically.
Can you recommend maybe one specific or even two sensors for such a specific approach for an entire fleet?
Yes, so if you think about, you performed your health ranking, you know the most valuable also assets, but also the most critical assets, then you go and apply monitoring. Then it's useful to have a look into secret statistics, failure statistics, and you will see that the most critical part of the transformer is the active part itself, the winding and the paper, of course, around the windings. To monitor this in an efficient way, the technology to use is DGA. It's proven right now. It's been there for many, many years, hundreds of thousands of units sold. And so this is really something that is proven in the market, that works, and should be applied, especially on the critical transformers, if you want to have a list where to invest first. And there are several options for DGA. There is one key gas, the hydrogen, for example, that is part on most of the major incidents in active parts. So that's why hydrogen should always be measured.
Okay.
And then you have to see, okay, do I have the budget to apply DGA on every transformer? Maybe single gas sensors, two gas sensors. If I have very critical transformers and I want to analyze also the gas patterns, then also maybe a 9-gas sensor makes sense. So this is really a step-by-step program, but DGA would be the technology to monitor the most critical component, the active part itself. And then there are two more very critical components. One is the tap changer and one is the bushings.
According to the secret study.
According to the statistics, yeah. So for the tap changer, for example, what is problematic for the tap changer? It's bad oil quality.
Correct, yeah.
So it's useful to have some kind of idea what the oil is doing. And there are very simple sensors available for that solution, which is measuring the moisture. Having an idea about the moisture, then you can calculate the breakdown voltage. Also, you have an understanding about what the oil quality is doing. And then as the on-load tap changer is the only moving part in the power transformer, it's also sensible to monitor the acoustics of this moving parts, as it's done for almost every wind turbine, for example. Yeah. So this is a basic technology used for very many wind turbines, and we use the same technology with our improved algorithms, especially for the tap changer. And we can detect mechanical problems there in case something happened to the tap changer. We will detect it. We will inform the customer or the utility that there is a problem.
Would it detect also a timing issue or timing difference?
Yeah. Typically, one switching operation is 5 seconds or something. And in between those 5 seconds, there is one part of the tap changer, which is called the diverter switch. And this operates in only less than 100 milliseconds, for example. And this is where a lot happens, and where you can also see the timing of the different contacts moving and switching, and there you can see a lot, actually.
So it can all be healed out.
Yeah, this can all be analyzed, and this can be used as part of the whole monitoring of the tap changer. And then, of course, bushings. Bushings don't have a protection device. That means that, for example, a transformer, when there's an incident, there's gas generated. You have a Buchholz relay. The Buchholz relay triggers the transformer, so it's hopefully shut off before the transformer blows up.
Or the bushing. Yeah.
But the bushing doesn't have such a protection device.
That's
so
correct, yeah.
When there's a partial breakdown, for example, you don't detect it because, let's be honest, how often do bushings get measured in the field? I talk to customers, they do it every 10 years, for example. So you are blind in between 10 years. Maybe there are customers who haven't done it, actually.
This is the same with the DGA. You take an oil sample, maybe every year, but in the meantime, there's a huge gap.
Exactly. And especially for bushings, I mean, it's such a struggle to make the diagnostics measurement. You have to shut off the transformer. You need an expert to perform the measurement. There's a lot that can go wrong there and can be made wrong there. And you don't know what happens in between those intervals, like you said.
Especially when an oil-filled, the OIP bushing is exploding, you can really lose the entire transformer, a very important asset then maybe to monitor that closer.
Exactly. And I mean, even if those incidents are not very probable, in a whole transformer fleet, they might be probable to even happen every year or two.
Less percentage, but a high risk.
Exactly.
So we have two sensors for the tap changer you mentioned, moisture, vibroacoustic monitoring, the bushing monitoring, and to start with, it was the dissolved gas analyzers to monitor, maybe starting, of course, with the critical transformer, and then, of course, depending on the available budget, maybe add another sensor or go higher with the multiple gas sensoric.
Yeah.
Okay. Exactly. Yeah. The strategic approach must fit to the individual needs. Yeah.
Absolutely. And I think it makes sense to make a plan first.
Absolutely.
So this is really something where it's useful to have consultants, to have someone having done this in the past, to know how a fleet ranking, fleet assessment works, and where to apply monitoring and to which extent. So this is really something where you need to put in a lot of work into the plan, I would say, and not use the budget, buy a lot of expensive sensors or very few expensive sensors, and then see, okay, I can't really handle these sensors properly.
It's smarter to make a plan. It will pay off then in the end of the day. Yeah. Can you maybe tell us a success story or a project where you have been involved and the sensoric digitalization was detecting an error and failure or protecting even the transformer?
Yes, there was a case not too long ago in Asia. We talked to this power utility. It was the asset manager. We talked to them and suggested our solutions and also made clear the advantages of using them. So first of all, the asset manager was quite, I would say, skeptical, but agreed on using it on a specific transformer.
Like a trial, yeah.
Like a trial to test it and to see what these technologies are capable in the past. Maybe they had problems with, like I said, the bad electronics from 10 years ago, or they had problems with a supplier that is not there anymore, or they had problems with too much data and didn't know how to handle it. I don't know. But they said, okay, we're going to test it on a trial and let's see if it can really bring us any benefit.
Output, yeah. Okay.
So we applied it, transformer was working, everything was well. And after a short amount of time, I would say like 2 months or so, they contacted us. They said, okay, your sensors and your system doesn't work. So there's a problem. They show us events. They show us that there's a problem with the transformer. And then we said, let's discuss this. Let's have a look on the data. And the system indeed suggested there might be a problem with the windings. And the next action step would be to get all sample analyzed in the laboratory. And so we said, yeah, please just continue like the system offers you. And we would say, now looking into the data, that this might be a real problem with the transformer. And the customer was really skeptical and said, yeah, he's not sure, but okay, let's have an oil sample and let's try in the getting the information clear on the table. So that's what they did. And the laboratory actually confirmed that the DGA sensor was what the DGA sensor was measuring. And the system said problems with the windings. And so it's still now in the discussion with the transformer manufacturer. They have a problem, that's for sure. Still in the phase of getting the error
solved. But the system was analyzing it, so it was not a failure as maybe the first intention was.
But this goes to show the mindset of this specific asset manager, because he might have had problems in the past, but now it completely shifted. So first he thought this technology still doesn't work because I get false alarms. I don't want false alarms. But then they realized, okay, it's not a false alarm. I might have now the opportunity to switch off the transformer before something severe happened. And so they decided to invest more into those technologies. And like I said, have to apply or are now in the phase of applying more of these systems to their transformers.
I can truly understand that because I have a lot of friends also in the energy sector. And you maybe have some early adapters. You try a technology, and after some time, doesn't matter which technology it is a failing or no longer software updates available. So you try to do something, invest money, and in the end of the day, the technology was maybe not proven. So this early adapter is a good thing on the one side, but can leave a bad impression if you fail.
Absolutely.
Regarding cybersecurity threats, maybe you can give us input about what is MR doing to secure cybersecurity issues.
First of all, the buzzword here is security by design. So we make sure that when we are in the design phase of the product, we already take security measures, because you can't build security around a already existing product. This wouldn't work. So security by design. So we have a lot of security measures already in the development phase, technically speaking, because we of course get the questionnaires and we get the requirements by our customers, what they want, which kind of technical features they want to have. So this is something. Then we look into what is possible from a technical point of view right now. And then we let our device be analyzed from our customers directly, but also from third-party organizations that try to hack our systems. So this is something that we do technically speaking. But then, of course, also we have to take organizational measures. Everyone needs to be trained. We need to have a cybersecurity department dealing with threats, with issues, informing customers, providing firmware updates. So it's basically a big challenge for everyone involved, for the customers, for us, for our suppliers. So it's not just one single thing that we do, but it's a whole ecosystem, I would say, that we have built up and are still improving every day, I would say.
I hear that we also have a CERT team. So-called. Maybe you can explain what CERT stands for and means?
Yeah, so that's a good topic, actually. CERT is a Computer Emergency Response Team. So it's a team especially designed and formed to be an interface between everyone using our systems and our development department, or our organization. So they will deal with every problem that there is, informing customers, but also getting feedback from the customers, and also interacting with other teams from our suppliers, from other suppliers of the customer, in order to make sure to improve the systems security-wise, but also to inform about threats, inform about how to use the system, how to mitigate risks, and so on.
Thank you for your time, Tobias, and all the interesting insights you gave us today about digitalization on power transformers, monitoring, difference to digitalization, which sensors can be used, and about the strategic approach behind it. I personally really enjoyed the chat, so thank you again for your time. I want also to say thank you to everyone who was listening or watching or is following us on our different channels. Thank you very much for that. Hope you enjoyed also our today's episode. Stay tuned. There is more to come from the power behind the power.